All right, one more minute. Once again, we are here at our Saturday Academy. What's that? Yeah, Nearpod, all you have to do is go in, type in that code, write your name, full name, period. All right? So without further ado, get your study guide in front of you. You should have 2 scratch papers also. Here we go. Problem number 1. First semester, final study guide. We're going to do 2 sessions. Hopefully we can finish half before the break. And then we'll do the second half afterwards. Here we go. Number 1, it says, write the domain and range of the function as an inequality using set notation and using interval notation. Also, describe the end behavior of the function or explain why there is no end behavior. Graph f of x equals negative x squared plus 3. So let me zoom in here really quick just to look at the graph. So they already give us the graph, which by looking at it, look up please. Let me show you some components. And by the way, at this point, make sure you put away your electronic devices. You can log in later and log in. I want those put away. I'm going to ask you to leave. Please. I can't be spending these 10, 15 seconds doing this. Yes? Thank you. X squared, we know it's a what? Oh, sorry. It's a parabola. My goodness. All right, here we go. When it's x squared, it's a parabola. Yes? And usually when it's just x squared, it's going through the point of origin, which is what? 0, 0. The general parabola looks like this. F of x equals x squared. And these points right here, which usually they're going to give you for this first one, they're going to give you the graph. But the points are here, 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 and here. How do we get those points? Well, x, f of x. You guys remember that? What values do we use, guys, most of the time? Negative 2, negative 1, 0, 1, 2. So, if I substitute this in here, negative 2 squared is 4. Negative 1 squared is 1, 0. 1 squared is 1. 2 squared is 4. So to graph this is negative 1, 1. It's right there. Negative 2, 4 is right there. And the same thing for this side. 1, 1, and 2, 4. And that's how you get those points. Now, are they going to ask you to graph this on the very first one? No, I'm just showing you, refreshing your memory in regards to how to graph these. Is it coming back? Yes? Yes, Mr. Q. All right. So, now that we're there, they want us to find the domain. Now, for the domain, remember when we covered the domain, I asked you guys to use your highlighters to help you out? I'm going to do the same just to refreshing your memory. So at the day of the parte, you may use your highlighters, by the way. So make sure you come ready with your stuff. So domain, they're talking about the entire x-axis that is part of the graph. So here we go. I'm going to start in the far left. So I'm going to highlight the function. All right, there it is. And I'm going to highlight till the end of the function. Okay. All right. Now, who notices? Can you guys see from there? Yeah? Hold on, let me change the... better? Right there? All right. So, Look up, please. Now, if this did not have an arrow, look up to the screen. If this function did not have an arrow here and here, my domain would be from what? From -3 to what? To 3. But since it does have an arrow, what does that tell us? That it keeps going to the left all the way to what? -infinity, and all the way to the right to +infinity. And to remember that, make sure when you get to these, you're like, oh, let me continue. Because of the arrow, I need to highlight all the x values. All the x values. There it is. So, let's write that in... It just asked us for set notation? Okay. Well, before that, here we go. So, -infinity to +infinity, and it's x, and it's what? Less than and less than. Why don't we put the equal sign? Because we never reach infinity. So, if this is my inequality, set notation is what? Solution set of x, such that -infinity less than x less than +infinity. Is it coming back? Yes? All right. Interval notation. Interval notation, there's only two ends. It's either in parentheses. Parentheses means that not included. And if it's bracket, it means what? Included. So, did we include here the infinities? No, because it doesn't have the equal sign here. So that means we write what? Parentheses, -infinity, comma, +infinity, parentheses. All right, let's go to the range. The range, they're talking about the y value. I'm going to change highlighters to pink. So I'm going to start from way down here, because we always start from the negative side of the value that we're looking at. So we're looking at the y-axis. So let's see. Does this graph start right here? Yes. Hold on. I'm going to highlight going up. Where does it stop? Tell me where to stop. Right there. Okay. So my range ends at +3 of y, or of f of x. And it starts here. Does it start here? No, since it has arrows and it keeps going, that means it keeps going to -infinity of the f of x. Is that correct? Yes, Mr. Q. So how would we write the range using 3 and -infinity? So it would be like this. -infinity less than f of x less than or equal to 3. Y equal to. Tell your neighbor y equal to 3. Because 3 is part of the graph. It does include the graph. It's right there on the curve. Okay? So write me the set notation and the interval notation for the range, please. Bless you. Got it. Is it coming back? Yes? Not yet? Maybe you need to have your Johnny burrito. Wow. They should pay me for those commercials on YouTube, right? All right, let's see. Who got this? Solution set of f of x such that -infinity less than f of x less than or equal to 3. How do we write the interval notation here? Parentheses for the -infinity, comma, +3, and it's what? Bracket. Hands if you got that? Okay. And behavior. All right, so I'm going to erase this so you guys can see what I'm talking about in regards to behavior. I don't want you to get confused with what I wrote before. Ready? Here we go. So I'm going to erase this. Or let me do this so I don't lose this screen. All right, let me zoom in. Okay, look at the graph. We have two ends of this graph, this end and this end. I'm going to start with this one right here. And I'm going to focus starting from 0, and I'm going to look at the x values first. So here we go. X, let's see, when I have 1, the value of y is 2. You guys see that? It's right there. 1 of x, 2 of y. Okay? When it's 2 of x, it's negative 1 of y. I mean, negative 1 of y. When it's 3 of x, it's negative what? 6 of y. So let's see. The y started at 2, then we went to negative 1, and now we're at negative 6. But the x's, what did I start with? 0, 1, 2, 3, and I keep going. So in what direction is x heading for that end? Positive infinity. Okay. And what's happening to the y values as we continue going to positive infinity of x? It goes to negative infinity. So therefore, we write when x approaches positive infinity, comma, f of x approaches negative infinity. And here it goes again. Why is that, Mr. Q? I didn't understand. Here it goes again. I'm going to start with 0 of x. 0 of x is right here, okay? This is y. What number is it? 3. 1 of x, 2 of y, that point is on the function, yes. So what number is the y value? 2. 2 of x, the y value for that point is negative 1. So notice, it goes from 3 to negative 1, and now the next one is negative 6. What's happening to all these values? They're going to what? Negative infinity. Yes? Yes, Mr. Q. All right. Let's look at this side now. I'm going to look at the other side. Here we go. From the center to the left. Let's see. 0, 3. Okay, so it's right there. 0, 3. Negative 1. And what is this value for y? 2. Okay. Negative 2 of x, what is the y value? Negative 1. Okay. Negative 3 of x, what is the y value? Negative 6 again. So what do you guys notice from the y values? That they started at 3, it went to 2, negative 1, negative 6. So as we continue on the x values going in that direction, so what would I write? X approaches negative infinity. F of x approaches negative infinity also. Why? Because it's going to continue going in that direction. Show me your fingers how complete you are with these. Okay. All right. All right, let's go to number 2. Here we go. Let me zoom up. It says, a fireworks projectile is launched at 20 meters per second from a 60-meter cliff. The table shows the height in y in meters of the projector is above the field after x seconds. Here's the table, and look at the instructions. Part A, plot the points and make a curve. I want you to do that, please. These are your coordinates. Plot me the points and make a curve, please. I'll give you a head start. All right, I'm going to use blue to plot my points. My first point is 0, time. So this is time. I'm going to label that. That's my x. And for my y, they label it y, is this one. So 0 of x, 60y. 0, 60. 1, 75. 1. This is 70. 75 is about right there. 2, 80. to 80. 375. 460. 535. Is it 35? Yeah. 35 is about right there. All right. So, draw your curve. All right, let's answer the question. It says, what is the maximum height of the projector? Write it in there, please. Share it with your neighbor. Maximum height. All right. Jalen, what'd you get? No, the other Jalen. Be nice. Very good. You said 80 feet. Hands if you got that. That is incorrect. It's 80 what, everyone? Meters. Oh, my goodness. Come on, Jalen. You just made the YouTube video. All right. Part C, it says, over what interval, pay attention to this part. Look up, please. Box this word, interval. Why? Because that's how they're asking us to write it. Using what? Interval notation. Those of you that loved interval notation. Right, Aldo? All right. It says, over what interval is the projectile height increasing? That means we need to look at the x values. I'm looking at these values, guys. These values to find out when it's increasing. All right. So between what and what? From 0 to what? From 0 to 2. So I'm going to write, does it include 0? Yes. So we do bracket 0, comma 2. And that is the time. Yes? All right, but now I want you to write it in regards to the height. I want you to write me the interval notation for the height. Right now I gave you the x value, so now what are we going to focus on now? The y, yes. All right, show your neighbor, see what they got for the interval for the height. When is it increasing? Between what intervals? All right, let's see. Do I start way down here? No, I start right here. Right there. Between what interval is it increasing? 60 all the way to 80. Oh my goodness. So then we should have written what? Bracket 60, comma 80. We got it? All right, so now I want you to write me the interval notation when the projectile's height is decreasing. I want the time and I want the height, both interval notation. Do that right now, please. All right, for those of you that are following on the video, so here the projectile is increasing from here to here. That's why in height it goes from 60 to 80. And in time, it goes from 0 to 2. However, the decrease starts right here. It starts decreasing all the way down here. This is my decrease. So according to my x values, where does it start decreasing? At 2, and it goes all the way to what? 6 or 6 point something. That's for the time. So, what would we write? Bracket 2, comma, 6. I'll take that for right now. That's fine. What's that? 5? Okay, 6. And the height, when does it start decreasing? It starts decreasing at 80. And where does it stop, everyone? At 0. That is correct, because that's when the projectile is already on the floor. Hands, have you got that? Okay, good. All right, let's move on. Number 3. Here we go. It says, describe how to transform the graph f of x equals x squared to obtain the graph related to the function blah, 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 blah. So, ready? So, they're asking you to describe first that one. What does that mean? That I need to graph that one. So, I'm going to give you a head start. Graph that one, please. By now, you should know how to graph f of x equals x squared. Go. All right, here we go. You should have done what? X, f of x, yes? Negative 2, negative 1, 0, 1, 2. So for this one, if I substitute negative 2 in here, what is negative 2 squared? Well, isn't that x squared? Yes, that's 4. Next value, negative 1 squared. 1, 0 squared, 1 squared, and 2 squared is 4. So to get started with your pencil or in black, I want you to graph this. 0, 0, negative 2, 4, negative 1, 1, 1, 1, 2, 4. All right? Are we doing good? Okay? So let's see. Look up, please. According to what we see here, what is the vertex? Talk it over to your neighbor. What would be the vertex? Who said 0, negative 1? That is correct. Now, those of you are already started seeing it through the eyes of the transformation. Here it goes again. If you don't see it, it's because of this. Remember, with our transformations, look up to the screen. We have parentheses x minus h plus k. Is that correct? That means the h is part of the vertex and k is part of the vertex. So look at the x here. Is there a number inside of the parentheses next to it on the right side? No, that's why I wrote what? 0. What's outside the parentheses on this one? K. So what's outside of the parentheses here? Negative 1. That's why my vertex is 0, negative 1. So let's plot that really quick. 0, negative 1. No? What is it? All right. So it's 0, negative 1. Very good. All right. So here we go. How do we get the points, Mr. Q? Here we go. I'm going to use blue for the new transformation. That means we need to add right here. Remember these? Oh, yeah. And we're going to write this right here. We're going to write, not f, let's just write 3x squared minus 1. Why squared? Because this is saying f of 3x. That means to the x, what do we do first? Multiply times 3 before we do what? Square and subtract 1. So let's see. What number do I substitute in here? Negative 2. What is negative 2 times 3? Let me write it out. 3 times negative 2 squared minus 1. So this is negative 6 squared. What is negative 6 squared? 36 minus 1, 35. Next, parentheses, 3 times negative 1 squared minus 1. So what is 3 times negative 1? Okay, once again, what is 3 times negative 1? Negative 3 squared, that's positive 9 minus 1, that is 8. And of course, this one is what? 0. This one is what? 8. And this one is what? 35. So which are the ones that we are able to graph? What's that? Where? Oh, my bad. This is negative 1. Sorry. My bad. Negative, oh, this is positive 8. Negative 1, positive 8. Yeah. Sorry. All right, so let's graph these. These three with these x values. Here we go. Negative 1, positive 8. Negative 1, positive 8 is right third. Zero, negative 1, we already have it. 0, negative 1. And 1, positive 8. 1, positive 8. So what just happened to it? It stretched, didn't it? Vertically. How we doing? What's that? Can we... The question was, can we graph negative 2? Let's see, negative 2, 35. Let's see, negative 2, 35. Oh, I can't fit it on my screen. All right. Do we do another one of these? We got it? All right. On your blank sheet of paper, write this down. F of x equals x squared. This is number 2q. And we want to do, let's see, this previous one was, okay. We're going to do g of x equals f of 4x minus, give me a number, 2. All right. We're not going to graph it. I just want to see if you make the table correctly. Here we go. What's the table for this one? Well, x f of x. Negative 2, negative 1, 0, 1, 2. What are the values here? By now you should know them by heart, yes? What goes here? 4, 1, 0, 1, 4. Those never change. They're always the same. So you remember what I just said. Next, you add a column. And tell me what to write, Jalen. Yes. Very good. Parentheses 4x squared minus 2. So I'm not going to write the work here. By now we're going to do this in our noodle. Here we go. What is negative 2 times 4? Let me repeat that again. What is negative 2 times 4? Negative 8. What is negative 8 squared? 64 minus 2, 62. Next one. What is negative 1 times 4? Negative 4. What is negative 4 squared? 16 minus 2, 14. Next value. What is 0 times 4? 0 squared, 0 minus 2, negative 2. Next value. Tell your neighbor what the next value without even doing the work. 14. And the next one, 62. So which ones will be the most probably ones that we graph? 14, negative 2, and this one with their respective x values. And that's the transformation. We got it? Yes? The square comes from the original function. Remember, we're transforming this function, and these are the instructions. Guys, look up to the screen. Look up. This is saying f of x, we're going to do what to x? Square it. But this one is no longer f of x. What is it? F of 4x. And then we're going to square it. And then at the end we do what? Minus 2. That's why we write the square right here. All right? Show your fingers will come through out with these. Okay? Let's move on. Number 3. Oh, number 4. My bad. All right? It says, find the inverse for the given function x, f of x. Use composition to verify that the functions are inverses. Then graph the functions and its inverse. So, what is the first step to doing the inverse? Let's see. Everyone? Very good. We change f of x to y. Come on, people. Equals to 3/4 x minus 1. What do we do now? We solve for x. So, line down the equal sign, and we do plus 1 plus 1. We end up with y plus 1 equals 3/4 x. All right, and here we go. I'm going to go one step at a time with this, so like that we can rewrite this. We need to get rid of the 4 that's dividing. What do? Times 4 times 4. All right, so we end up with 3x equals, and let's distribute here. What do we have? 4y plus 4. What's my last step? Divide by 3, divide by 3. We end up with, let's see, let's write this as a fraction. We got what? I'm going to rewrite this over here. 4y plus 4 over 3 equals x. All right, before I transform it to graph it, let's exchange. Who remembers what to do at this point? We change the x and the y, because that's what we call the inverse. So we end up with 4x plus 4 divided by 3 equals y. Yeah, this is the inverse. Okay? So right now I'm going to leave it like that, but what's the next step? 4x plus 4 over 3 equals f of negative 1x. That's what tells us that it's the what? The inverse. All right. But can we graph this, by the way? Like this? No, we need a slope-intercept form. Is that correct? All right, so let me move this up. I'm going to change it to slope-intercept form. Let's leave this as a fraction. So what is 4 over 3 in a fraction form? It's 4 over 3x. Plus, what is 4 divided by 3? 1 and 1/3, or 1.3, equals to this. I'm going to leave it in y form so we can graph it. So, before I showed you the part that some of you struggle with, which is the check, let's graph these. Yes? So, this one to graph, we need to use this one right here. What do we need to graph? We need the y-intercept and the slope, yes? All right, I'm going to give you guys a head start on that. Graph this one, and then graph this one. Use those colors, please. I'll give you a couple minutes. All right, let's see where we're at. I'm going to graph this one in blue. Where do I start? At negative 1. So negative 1 is right there. What is my slope? 3 up, 4 to the right. 1, 2, 3, 1, 2, 3, 4. And I graph my line. I'm going to do that in blue. Now I'm going to graph this one in green. Where do I start? Positive 1 and 1/3. Positive 1 and 1/3 is 1, and 1/3 is about right there. Let me zoom in so you guys can see it. 1 and 1/3. Okay. What is my slope? 4 up and 3 to the right. So I go 1, 2, 3, 4. 1, 2, 3. Let's see how that looks. There it is. Okay, here it goes once again. For those of you that are struggling with graphing, this one we start at what? At negative 1. There it is. What is my slope? 3 up, 4 to the right. 1, 2, 3, 1, 2, 3, 4, and I graph my line. This one, where do I start? Positive 1 and 1/3. 1 and 1/3 is a little bit higher than that. From there, I go 4 steps up and 3 to the right. That means at every 1/3 going upward, I'm going to do 4 steps. So here goes 1, 2, 3, 4, and 1, 2, 3. Hands if you got that by yourself. Okay, good. All right, and here goes the fun part. Ready? Yes. Sorry? Can I, oh, zoom in? All right, let's do the verify. How do we verify? Or how do we check? We check that f of x at the end has to equal to x. And then we check that f of negative 1x is also equal to x. I'm sorry? Let's see, what does it say? It says, use composition to verify. Yes, you need to do that. Okay, let me zoom out, and I'm going to write big so you guys can see it. Here it goes. So, I'm going to start with f of x. Ready? This is where it gets a little funner. F of, open a parenthesis. And what do we need to check? We need to check that the inverse f of 1x, all that's going to equal to x. All right, so follow along. Here we go. I'm going to write this one. Look up, please. Draw an arrow, so like that you know where I got that from. And I'm going to write f of, big parentheses, f inverse of x equal to, now instead of writing x, I'm going to write whatever this was. What was it? 3/4, and do a big parenthesis for the x. And then minus 1. Did everybody see that I wrote this from this right here? Yes? Okay. What did we get in the inverse? What was the inverse? Let me see. The inverse is this right here. Do you guys see that f of negative 1 is that? So I want you to draw an arrow because we need to substitute this in here. So we write 4x plus 4 over 3. All right? So let's simplify. F of, I'm just going to do it all in black from right here on this side, negative 1 of x equals 2. Here, I'm going to distribute. I'm going to do it in red so you guys can see it. What is 3 times 4x? 12x. What is 3 times 4? 12. Over. What is 4 times 3? 12. And all that minus 1. Are we there so far? Okay, good. Let's go to the next step. F of negative 1 of x equals, let's see. What is 12x divided by 12? 1x. What is 12 divided by 12? 1, and bring down the negative 1. So lastly, we end up with f of negative 1 of x equals to, what is 1 minus 1? 0, and we're left with x. Did we end up with what we wanted to check? Yes. Pretty cool, huh? All right, so we're done with 1. Let's do the other, right here. F of negative 1 of x should be equal to x. So we do f of negative 1, big parentheses, equal to, what goes in the parentheses? We're going to write just f of x. All right. Now, what was f of negative 1 of x? Let me look again. F of negative 1 of x is this. 4x plus 4 over 3. That goes right here. Let me show you. 4, big parentheses, plus 4 over 3. However, instead of writing here x, what am I going to write? Whatever f of x was. What was f of x? F of x is 3/4 x minus 1. 3/4 x minus 1. 3/4 x minus 1. Let me zoom in for those of you that can't see from the back. You guys remember these? Yes? You're like, I don't remember, Mr. Q. I just copied the home plate from somewhere. Oh, okay. All right, let me rewrite this. F of negative 1 times f of x. Oh, I'm sorry. F of negative 1, f of x equals. All right, so let's distribute here. What is 4 times 3? 12 over 4x. What is 4 times negative 1? Negative 4. Then we bring down the plus 4 and all that over 3. Let's see if you can finish this off by yourself. What is 12 divided by 4? 3x. What is negative 4 plus 4? Cancel, and this over 3. F of negative 1, f of x is equal to x. Did we end up with x? Yes. And we're done, because this is 3 over 3, which is 1. Hands, have you got that? Yes. Let's read the instructions again. Verify. Yes, that's what we're doing right now. Yeah, or else I wouldn't go over it. Look at that beauty. Q merch, yeah? Okay, is it coming back? Yes? All right. So, multi-part problem, let's see. First part, do the inverse. Write it, graph both of them, and do the check for both. All right, number 5. Okay, for this one, I'm going to give you a heads up. And I'm going to have someone help me find the vertex. How about, Jalen? What's the vertex? What is it? 2, -7. Hands if you got that. That is correct. Remember when we have transformations, we have a parentheses x minus h, and then outside we have the plus k. So what is h here? 2. What is k? -7. That is correct. Plot that. 2, 7. Oh, -7, not bad. Yeah, I did that to see if you're paying attention. Be nice. Should be just about done graphing this one, yes? Now, this should be a piece of cake because we did this all week, right? On the warm-up. So what do we use? What is our slope? 3 up, 4 to the right. So we go 1, 2, 3, 1, 2, 3, 4 to the right. Be careful because these are going by 2s, yes? So you have to go halfway on each. Then we do the same to the other side. 1, 2, 3, 1, 2, 3, 4. and you graph your function. Piece of cake. Let's do another one on that same one. I want you to graph this one. G of x equals absolute value 1/2 parentheses x plus 3, close the absolute value. What else? Plus 4. I made this one up. Example 5Q. I said I'm going to give you another one. Should be almost done. Once again, thank you for staying off those electronic devices. Sammy? Can you guys see the cameras? My goodness. All right, let's see. What's our vertex, everyone? -3, 4. Why -3, Mr. Q? Because the original transformation equation has a negative here. Do you guys see it? Is this a negative? No, that means we needed to substitute -3. So, -3, 4 is right there. What's my slope? 1 up, 2 to the right. 1 up, 1, 2 to the right. And I do the same to the other side. 1 up, 2 to the left. And there it is. Hands if you got that. Yeah, you guys better be getting these. We did this all week. Oh my goodness. And what did I say on Tuesday, Wednesday, Thursday, Friday? Any questions with a warm-up? Yes. I did 3? Let's see. 1, 2, 3. 1, 2, 3, 4. 1, 1, 2. Oh yeah, it's right here. My bad. 1, 1, 2. My bad. There it is. Thank you. All right, so maybe we're going to come to you out with these. Yeah, we got this. Let's move on. Number 6. It says, isolate the absolute value. Determine if it can be solved. If so, find and graph the solutions. If not, write no solution. So, let me zoom in. Or I'm going to write it over here a little bit bigger. -8, absolute value, -x minus 6, close the absolute value, plus 10 equals to 2. Write that on your right side, please. All right, with these, what is the most important step? To isolate the absolute value. I even wrote it here at the beginning. You need to isolate it before you do anything else. So what do we have outside the absolute value? Some of you are like, what does that mean, Mr. Q? Draw your line down the equal sign. Look at the absolute value. Does it have anything in front, behind, or below it? Not below it, but on the side, it does. So that means I need to get rid of the addition first or subtraction. So what do? -10 minus 10. We're left with -8, absolute value, -x minus 6 equals -8. Am I done leaving the absolute value by itself? No, I need to do what? Get rid of the -8 that's multiplying. So what is the inverse? Divide by -8, divide by -8. We're left with absolute value, -x minus 6 equals 1. What do we do from there? You guys remember? Is the absolute value by itself? Yes. So at this point we do two equations. One for -1 and one for +1. And what goes on the other side of the equation? Whatever's inside the absolute value. -x minus 6. -x minus 6. Let's solve. Add 6, add 6. -x equals 5. Divide by -1. X equals -5. Plus 6 plus 6. -x equals 7. Divide by -1. X equals -7. Is it coming back? Yes? Yeah, I gave you some of these on the warm-ups also. Not this week, but the previous. So, let's plot our points. Were we able to solve it? Yes. -5 and -7. So let me plot those. -5 is right there, and -7 is right there. Do we need to highlight? No, it's not an inequality. We just plot the points. However, solution set, -7, comma, -5. All right, let's double check the process one more time. Step 1, the most important step, leave the absolute value by itself. So that means I get rid of anything that's around it, even below it. Once we have the absolute value by itself, we write two equations, one for positive, one for negative. There it is. Solve, plot, and write your solution set. So many people come to your with these. Yeah, we got these. Let's move on. Number 7. It says, solve each problem using an absolute value inequality. So I want you to double underline that so that you don't forget that now it's a what? Inequality. So let me zoom in. Dun, dun, dun. Are you guys seen that video where the squirrel is, it turns and all of a sudden, oh, gopher, my bad. All right, it reads, on average, a squirrel life is 6.5 years old. The lifespan of the squirrel may vary as much as 1.5 years. What does that mean, vary? That it can either be plus or minus 1.5 years. What is the average age of the squirrel's life? So, let's see. What is the first thing we write when we write an inequality or a function? We do absolute value x minus, close the absolute value. And for years or anything that they're giving us a top age, we do less than or equal to. Could the squirrel be 6.5 years old? Yes. But could it be less? Yes. However, could it be more? By as much as how much? That's how we know that that goes right here, 1.5. So that means the other number goes right there. Okay, let's solve this. Line down the inequality symbol. Question, what is the first step? Isolate the absolute value. The absolute value by itself. Yeah, so at this point we do what? Two inequalities. One for negative 1.5. Who remembers what happens to the inequality? You flip it. That is correct. And we write x minus 6.5. And for the positive one, that remains 1.5. We still write less than or equal to, and it's x minus 6.5. Bless you. Let's solve. Let's see. I do plus 6.5 plus 6.5. X is greater than or equal to 5. Am I right or am I going crazy over here? This one, plus 6.5 plus 6.5, x is less than or equal to 8. Now, we need to write, it says, what is the average age of the squirrel? But we need to write it in what? In an absolute value, in an inequality form. So let's graph this. Here it goes. I got 0. This one is what? 5. Close point. Let me test the point. Do I test 0? Yeah. Is 0 greater than 5? No, that's false. So I'm not going to go this way. I'm going to go that way. Next, I'm going to graph this one. 8. It's right there. Let me test 0 again. Is 0 less than or equal to 8? Yeah, 0 is less than 8. So I'm going to highlight towards 0. So what kind of inequality is this, everyone? And so my solution said I write it right underneath x such that 5 is less than or equal to x, which is less than or equal to 8. What would be a statement? Ask your neighbor, what do you write as a statement for this, for the squirrel? Very good. The squirrel's lifespan is from 5 to 8 years old. 10Q. Is it coming back? Yes? Okay, good. All right, let's go to number 8. Let me zoom out so we can see the beautiful work. Look at that. Let's go. Number 8. Oh, yeah, let's go. Number 8, it says, solve the equation using the indicated method. Number 1, graphing. Number 2, factoring. And number 3, square roots. Okay? I'm going to start with the easiest one, which is probably square roots. Okay? So I want you to write this right here. 3x squared minus 6 equals 6. 3x squared minus 6 equals 6. Write it underneath where it says square roots. 3x squared minus 6 equals 6. Let me zoom in. So we're going to solve by square roots. That means we need to leave x squared by itself. So line down the equal sign. To isolate x, what do I do, everyone? Plus 6 plus 6. We're left with 3x squared equals 12. Divide by 3, divide by 3. X squared equals 4. And the last step, take the square root. That is correct. And we're left with x equals plus minus 2. Focus, please. What does that mean, Mr. Q? That means that we have two roots. Remember, x sub 1 is positive 2, and x sub 2 is negative 2. We have two solutions. Solutions. Okay? All right? So now we did it by square roots. Now we're going to do it by factoring. Let's go over here, write it again. 3x squared minus 6 equals 6. Now pay attention to this part because this is it's a little bit different from the previous one. On the previous one, we needed to leave x by itself. On this one, we don't. We need to get everything on the side where x is at. So line down the equal sign, and I need to get everything on this side. So what do? Minus 6, we end up with 3x squared minus 12 equals 0. Now that we have it equal to 0, now we can factor. What are we doing? Factor. So all this past couple of days, we did what? What was the process? Standard form. What is the second step? Check for GCF. So look at it. What is our GCF for these two? 3. And we're left with x squared minus 4 equal to 0. Am I done? No, look at this one. What does this look like? It looks like difference of squares. That means that it needs a pattern, right? Let's see. What is square root of this? It's x. Square root of this, 2. If it has a subtraction, then that means this can be written as plus 2 minus 2. Bring down the 3, and all that equals to 0. Now some of you are like, Mr. Q, I don't think I'm going to remember that. Okay, then let me do it another way. Look up, please. If you don't remember this pattern, we can factor this using power interest. What goes on top? Negative 4. What goes on the bottom? The middle term where x is at. Do we have an x? No, so it's what? 0. What factors of negative 4 add to give us 0? Negative 2 and 2. All right, let's finish it off. We need to set each one equal to 0, so we write 3 equal to 0, x plus 2 equal to 0, and x minus 2 equal to 0. Is this true right here? No, so we get rid of that. This one, we solve. Minus 2 minus 2, x equals negative 2, plus 2 plus 2, x equals positive 2. These are my solutions. Did we end up with the same thing we started over here? Same solutions? Yes, same solutions. All right, last but not least, graphing, the easiest one. Here we go. Let me zoom in. I'm going to write it here on the side. Let's write 3x squared minus 6 equals 6. Once again, we need to get everything on one side. Everything on one side. So we do minus 6 minus 6. We end up with 3x squared minus 12 equals 0. But since we're graphing, now we need a y value. Before it became 0, what was it before? Very good. 3x squared minus 12 equals y. Now we can graph. Is that correct? Is that correct? Yeah. So now we need a table. X, y. All right. So let's see. Negative 2, negative 1, 0, 1, 2. All right. Here it goes. I'm going to substitute my first value, negative 2. What is negative 2 squared? 4 times 3 minus 12, 0. Let's plot that. Negative 2, 0. There it is. Okay. Next value. Negative 1 squared. What is negative 1 squared? 1 times 3, 3 minus 12, negative 9. Plot that. 1, negative 9, way down here. Next, 0. What is 0 squared? 0 times 3, 0, we're left with negative 12. Let's plot that. 0, negative 12, which is down here somewhere. Negative 12. And what do we know about parabolas? What goes here? Negative 9, and here? 0. So 2, 0. 1, negative 9. And then you're going to point to these. Solutions. What are the solutions? Negative 2 of x and 2 of x. Let me zoom out. Look at that beauty. Humor, yes? Once again, square roots. I suggest you always start with the square roots because probably that's the fastest and the easiest one to come up with the roots. And that'll show you that if you make a mistake on the other ones, then you need to do the work. Does that make sense? Yes, Mr. Q. All right, number 9. I'll give you a head start for these. You should know these by heart by now. You should be waking up imaginary. Subtract. All right, you should be just about done. Here it goes. This one is a subtraction, so that means I need to distribute into both terms. Both terms. So this is negative 3 minus 2i. Bring down the other one. 5 plus 6i. But what am I talking about? You guys have been doing these like for 2-3 weeks already. Let's see, combine like terms. We start with a constant. What is 5 minus 3? 2. What is 6i minus 2i? Positive 4i, and we're done. That's our subtraction, or our difference. And have you got that? Okay, number 10. By the way, show me what the framework talking already. Yeah, we got these. Let's go to the product. Multiply. I'll give you a head start. Ready, go. Copy that and go. Should have multiplied already and simplified. 7 times 4, that's 28. 7 times 9i, that's positive 63i. 2i times 4, that's 8i. 2i times 9i, that's positive 18i squared. Combine like terms. 28. This becomes positive 71i. This one is 18i squared. However, the last step, since we already combined like terms, what do we know? That I squared is negative 1. We need to substitute that. But what am I talking about? You guys have been doing that. Woo. Negative 1. 28 plus 71i plus 18 times negative 1. This is what? Negative 18. Combine that with this. That gives us 10 plus 71i. And have you got that? Okay, good. That's the value of I squared. We've been doing these for 3 weeks. Yeah. I squared. Once again, to clarify, I squared is negative 1. Is that correct? Yes, Mrs. Q. What is I? I is square root of negative 1. Okay, good. Let's go to number 11. Here we go. There we go. It says, use a diagram of the electronic circuit and the given current to find the impedance for the circuit. First of all, let's write the names of each part to see if we remember what they are. Yeah, I want you to write the names of each part. Go. Very good. You should be done by now, right? Resistor. Inductor. Capacitor. Come on, guys. You should be like your BFFs by now. All right, and they want us to find the current going through each of those parts. So here we go. I'm going to zoom out. So before I get started with everything, the resistor. What is the value of the resistor? Who remembers? It's just a constant, so it's positive 6. What is the impedance for the inductor? 2I. That is correct. And for the capacitor, it's negative 10I. You guys remember these? Yes, very good. These are the impedance. Impedance. All right. But now they're asking us to find out how much current is going through each one, so I'm going to do this. Check this out. I'm going to write R for resistor, I for inductor, and C for capacitor. All right. So, who remembers the formula that we use? Remembers like a credit card? Not Visa, but it's Viz. Volt equals the current times the impedance. Label this, make sure you have this, because this is, you need to know this. Volt. This is current, which is this. And the Z is our impedance for each one. So what do we do for each one? We're going to write that formula and just substitute values. Okay, so let me zoom in. So I write V equals 1 times Z. So, I times Z, my bad. V equals, what is the current? I, 7.2 plus 9.6 I, times, what is the impedance for the resistor? 6, that is correct. All right, distribute. Let's see what voltage is going through that one. So my voltage going through that one is 6 times 7.2, that's 43.2, plus 6 times 9.6, very good, 57.6 I. That's the current going through what? The resistor. Is it coming back? Yes? Good. I do that again for the inductor. V equals I times Z. V equals 7.2 plus 9.6 I times, what is the impedance for the inductor, everyone? Let me check. 2I. So I write that right there. 2I, and I distribute. So I end up with V equals 2 times 7.2, that's 14.4I. 2 times 9.6, that's, bless you, 19.2I squared. What do we notice here, guys? That instead of I squared, what do we substitute at the end? -1. That is correct. Look up, please. Anywhere you see I squared, we're going to substitute a what? A -1. So we end up with voltage equals, what is -1 times 19.2? -19.2, and then at the end we write plus 14.4I, which is this. Yes? Yes. That's fine. Yeah, some of you are thinking, Mr. Q, how come you switch these? I want it written like this, but it's okay if you leave the I first and the constant at the end. Oh my goodness. Alright, and last but not least, capacitor. Here we go. V equals I times Z. V equals 7.2 plus 9.6I times, what is the impedance of the capacitor? -10I. -10I. I'll give you a head start so you can finish that one. Should be done by now, but let's see, we should have written V equals, was it -72I? Yes. And then -96I squared. And then for that one, we're going to substitute what? -1 for the I squared. So we end up with V equals positive 96. Oh, I don't need to write the positive. Let me erase the little sign. And what goes at the end? -72I. Hands if you got that? Okay. Now, for the study guide, guys, I included all three components. For the final, we might only ask you to do 2. But I wanted to show you all three so you can see the name and how to write all three. Okay? All right. Number 12. Last one so that we can go to break. Here it goes. It says, how many solutions for this one? So check this out. Step 1, is it in standard form? Yes. So therefore, we're going to use what? We're going to use V squared minus 4AC. Remember that? From the quadratic equation, or the quadratic formula, x equals minus b plus minus square root b squared minus 4ac over 2a. I said we're going to use just the inside. That's known as the discriminant. So there it is. So what is a here, everyone? 9. What is b? -6. What is c? 9. So let's substitute those values in here. negative 6 squared minus 4 times. What is A? 9. And what is C? 9. All right, let's see what we got. This is 36. Let's see, 9 times 9 is 81 times 4. That's negative 300 and what? 44? 24. 324. So, what is 324 minus 36? Negative 288. What does that mean, Mr. Q? Well, let me show you the little table. If we end up with a positive number, we have 2 solutions. If we end up with a negative number, 2 real solutions. We end up with a negative number, 0 real solutions. If we end up with a 0, 1 solution. So those are the options. So the question is, real or non-real solutions? Look at it. Well, let me ask you, we ended up with a negative, that means no real solutions. What does that tell you? That it's what? Non-real. So non-real. Yes. Now, why is it non-real, Mr. Q? Because if we put that in a square root, can we take a square root of negative 288? No, unless we get what? An imaginary number. So how many imaginary numbers are we going to get? Okay, let me rewrite this. Some of you are looking at me like, I don't know what's going on, Mr. Q. Negative 1 times 288. This is the same as square root of 288 times I. How many solutions do we get for square root of 288? 2, and since it has I, so therefore there are 2 imaginary solutions. Because it's positive, 2. All right? We're going to stop right there. We're going to take a break. I'm going to upload the first half. Give me a second. Numbers 1 through